Now, after we have discussed the basics of microwaves in the previous lecture, this is the basic of how to derive relations between fields using Maxwell equations. These are the basic Maxwell equations that we know. Relation between H and E. Now, del cross H is equal to J omega epsilon E. H is magnetic field and E is electric field. Now, we know that a cross product of a field can be written as the determinant form. This is the determinant form that we can write, and now we can expand the determinant getting these equations. These are the equations that we get. First set of equations from first set of determinant, and these are second set of equations that we get from this expansion. I have written gamma bar here because I have replaced dou by dou z with minus gamma, and in the derivation, in the expansion of the determinant, wherever you get the term dou by dou z, you have to replace it with minus gamma bar. So you get these sets of relations. Now from these sets of relations, now I'll tell you how do you get these equations, expansion of this determinant. Expansion of this determinant is like x cap into this dou by dou y into hz minus dou by dou z into hy minus y cap into dou by dou x into hz minus dou by dou z into hx plus z cap into dou by dou x into hy minus dou x into dou by dou y. The similar thing is with this determinant. Now from these set of equations, we will now see how you find out relation between, equations for Ex, Ey, Hx, Hy. These will be used in the next lecture. Now, after that expansion, you can write, you can use the equation 1, of first set and equation 2 of second set. That is this both. These both can be used. That is, you write Ex, you take this J omega epsilon this side. So you get Ex is equal to 1 by J omega epsilon dou by dou y hz plus gamma bar hy. Now you put this equation in 2 of second set. Then you get dou by dou x of Ez plus gamma bar into Ex. So Ex we substitute the above equation. That is 1 by J omega epsilon dou by dou y hz plus gamma bar into hy. That is as usual equal to minus J omega mu hy. So this in this way you get an equation for hy. You can derive hy from here. That is, you take this minus 1 by J omega mu this side to the LHS side, and so you get this equation for hy. Similar way you can get equations for hx, ey and ex. I'll tell you one more example. That is, you write Ey from here. Ey is equal to minus 1 by J omega epsilon and this part, LHS part. Now you substitute this Ey in this equation. So you get Hx. The similar way you can derive for Hx and Hy also. That is, you put you take this minus 1 by J omega mu this side and substitute this in this second equation. So you'll get Ey. The similar, this method is used to get these equations. These are the equations you have to remember for the next lecture.